Another way they could ask you to find the minimum maximum value of a particular question is in terms of a graph, okay? So it doesn't always have to be area and so volume and what have you. It can be applied in this kind of context as well, all right? So what have we got here? They've given you the diagram of a parabola, okay, which is given by the equation negative 2x squared plus 6x, and of a straight line graph, which is 2x, okay? And then do you see that there's a line between the two of them over here, this line PQ, which is kind of a space between the two functions, okay? Now the question basically is saying that it's all very wordy, but they're saying that point P is on the parabola, point Q is on the straight line graph, and that creates the line PQ. And here's the question: calculate the largest possible length of PQ. All right, so this is the idea. If I was able to move PQ, this line of PQ, between those 2 points of intersection, there's going to be some points at which PQ gets a bit longer, and then there's going to be points at which PQ starts getting shorter and shorter, right? So as we kind of get closer towards those 2 points of intersection, so the line would obviously end up getting shorter and shorter, but we kind of want to know at what point would PQ stretch out to be the longest length between the 2 points of intersection. Okay, how do we do it? The first thing you need to do is you need to come up with a formula that represents the line PQ, all right? And if you are ever working with a line that is squeezed between two other graphs, okay, the best starting point you can have is to start by taking the top graph, and you're going to minus the bottom graph, because that's essentially then the distance between point P and point Q. So the top graph in this case is the parabola. The bottom graph is the straight line, okay? So negative 2x squared plus 6x, negative 2x squared plus 6x, which was the top graph, minus the bottom graph. And let's just make sure the bottom graph was just 2x. So I'm minusing the bottom graph from it. That's giving you an equation that represents the line PQ. I can tidy it up ever so slightly, and we can make it plus 4x. Okay, so that line is now representing your distance from P to Q. We now need to take that and calculate its maximum length. How do we do that? Well, the first thing we're going to have to do is to work out the derivative of your line PQ in terms of x, because that's the variable, and we are going to let it equal 0. Okay, why? Because to find minimum or maximum, we let derivative equal 0. So what have we got? I'm going to let it equal to 0, and I'm going to get the derivative, which is negative 4x plus 4. All right, let's move negative 4x over, in which case it will become positive 4x equals 4, and x equals 1. So the point at which PQ is at its longest is where x is equal to 1. All right, great, but is that what they asked me? They didn't ask me what is the x value where PQ is its longest. It says what is the longest value. So we're not done yet. We are now going to have to say, okay, well, if x is 1 at the point that it's its longest, we're then going to have to take it and substitute it back into the equation for PQ to work out its actual length. So the actual maximum length of PQ, where x was equal to 1, is going to be negative 2 times by 1 squared plus 4 times by 1. So we've got 1 squared is obviously just 1, so that's negative 2 plus 4, and we are getting 2. So what you know for absolute certain in this case over here is that the longest that PQ is going to get between those two lines is 2 units. Okay, pretty cool. Hey, so the way we worked it out, find the equation that represents the PQ. Once you've got that, find its derivative, let it equal to 0, and you've got what you needed. Okay, well done. We are going to have another example of two-dimensional questions. So do that one, and then we'll go on to the three-dimensional with volume and surface area.